As you can see, each LED strip has 3 inputs and 3 outputs. 2 of these inputs are 5 volts and ground to power the LEDs. The data in signal is a pulse width modulation signal from the Arduino, which tells the LED strip which LEDs to turn on which colors. And then, we can chain them with other LED strips using the 3 outputs. Just like the inputs, there are 2 5 volts and ground, so that they can pass them on to the next LED strip. However, there's also a data out pin, so that the LED can pass on the pulse width modulation signal to the next LEDs, letting them all be controlled by the same pin. So this is the main circuit controlled by our Arduino here. So first we have a real-time clock plugged in right here, and it's plugged into our power and ground rails up here, which connect back to the Arduino. And then we have the 2 data pins connected to the real-time clock, going from the breadboard into the analog 4 and analog 5 pins, and it uses these to update the time about every 15 seconds to check which LEDs should be displayed inside the clock. You can see the real-time clock has its own coin cell battery, so that even when this Arduino is unplugged and the clock as a whole loses power, this little trinket can keep track of the time on its own for up to 7 years. Then we have the data pin here sending the signal to LED strips through this resistor to protect the LEDs, fished in here and into the rest of our circuit. And in addition, we have 2 500 microfarad capacitors here in parallel, just to simulate a 1000 microfarad capacitor, as a bypass to protect the LEDs from any jumps in voltage.